In this video, we'll be learning how to debug a linked list using only pen and paper. Here we've got a program that creates a linked list of length 7 and then it prints it out. But unfortunately, when we run it, instead of getting what we expected, which was just to create an ascending linked list from 0 to 6, it instead does something else. So we expect something along the lines of but unfortunately, when we run it, what we get is actually something closer to that. So where's the rest of our list gone? We're missing a big chunk of it. And instead of doing, say, GDB, which some, well, most of 1.5.1.1 probably won't know GDB, you can get out your trusty pen, which is why you should bring a pen to your exam, and go through the program line by line and just sort of pretend you're the computer. So, if we have a look at this, it's a fairly long program. There's a couple of places this could go wrong, but there's places that we would look first. So we've got main, which calls two different functions. It creates a list, and then it prints this list. So, create list is probably the longest function of them all. And it looks a bit more complicated than the other functions. So, as we look at it, we think maybe our problem lies there. But it could be in create node, or it could be in print list, and it could even be in main. But if we have a look at print list, all this one does is go through in a while loop, prints out the data, and then sort of prints out the null, and then ends. So, it's probably not there. Like, it's a fairly straightforward function. There's other places that are more important to check first. Same with create node. All that does is it mallocs enough size for a struct node. So we check that we're mallocing enough size for struct node, not struct node star. That's another common issue that we see. But yeah, that looks fine. We check that that succeeded. And then we set the data and the next to null. So all pretty standard stuff. The only sort of weird code we might see is in this create list function. So we'll begin our search there. Length, we pass in 7 to this length. So that's now 7. And we'll just go through it line by line, writing out all the variables as they change, and drawing out our linked list as we've done here, but at different sort of stages of the program. So, we create a struct node head star, which is a pointer to null. So we start off with our empty list. Head just points to null. Nothing too exciting. Then, if length is greater than 0, we know that length is 7. Then we enter this if. All this if is doing is trying to account for that edge case where your length is 0. In which case, all you want to do is return that null. But we enter this if. So we can sort of ignore this outside stuff because that all looks fine. Problem's probably somewhere in here. Okay, so we create a node, and that will be created with the value of 0. So when we create our node, we pass in the data that we want to set it to. So at this line just here, what we're doing is we are setting head, instead of being null, that's now our newly created node. So head now becomes that. Okay. I becomes 1. Great. Then struct node star current is head. So that's making another pointer, and we're just pointing it to exactly the same place. Great. The while loop is another common place where you find linked list errors. So so far, it looks alright. We haven't added the rest of the list. So the rest of the code looks fine. The problem is most likely within this while loop. So, while I is less than length, I is 1. Length, remember we passed in as 7, so we enter this while loop. Struct node star new is create node. So we create a node with value I, which at the moment is 1, and that is now called new. Well, the pointer to it is called new. And that, by default, is made pointing to null. So we still have this guy. That's all good. The next line says new next is current. So we reroute new's next. Instead of pointing to null, which is as we created it to be, we now want it to be pointing to there. Great. Let's get rid of that. Okay. New next is current. So that line has been done. We're up to this line. Current is new. So we want to move this current pointer to be here. And I increments to 2. So after we've done one iteration of this while loop, it becomes 1 points to 0, points to null. And head is now pointing here, because that never changed. We never move head in here. And this becomes both new and current. I'm just rewriting that so it looks a bit neater. So after we've run this one time, that's what it looks like. Does that look right so far? Not at all. What we would want after one iteration is to probably have something looking closer to 0, that looks like a 6, 0, 1, null, where head is pointing to the first thing, which is 0, because we're making this list, remember. And 1, yeah, 1 should be new and co. And each time that we add a linked list node to it, all we do is we move both new and current along. And yeah, so these two clearly aren't the same list. So we need to work out what's gone wrong. So what we wanted to happen at this stage, which is inside our loop, is we wanted this guy to point to this guy instead of this guy to point to this guy. So the line that is doing that is this one. New next is current. So the new thing that we made, which is a higher number like 1, is pointing to the lower number, which is 0. We want it the other way around. So if we just swap this, if we say co next equals new, what happens then? Well, we can do exactly the same thing again. We can just say, go through it. So I think it starts off at 7. We can go a bit faster. I'm just going slowly because it's an introduction to it, but you should get quite efficient at this after you've done it a couple of times. So head points there. You create a node. Head points here instead. And then I is 1. Struct node star current is head. We just make it current pointer because we don't really want to move that head along. That's another common bug. Don't make that bug. And then, so we're up to here. We've created that new pointer. Well, I is less than length, so I is less than 7. We can go into that while loop as we did before. Struct node star new. Do the same thing we did before. We make new, which has got 1 in it, and points to null just as default. And we still have that, but instead of new next is current, we do current next is new. Current next is new. Great. So that then becomes, we need to do the rest of this line. So current becomes new, move that pointer to there. And then we increment I. So what that becomes is 0, 1, x. Head continues to stay there. New is pointing there. And current is pointing there. So this is a lot closer to what we wanted. And if we continue the loop, hopefully, it would produce the 0, 1, 2, 3, 4, 5, 6 null that we would expect. But it's at this stage that I would probably turn to my computer and make my computer do that instead, just because it's a lot faster at it than I am. So if we run this on the computer, and you can do this yourself, the file is available to download. It should be, if you're on the website, it should just be above it. Yeah, feel free to download that, run it, and yeah, you should get the expected output, which is this. Yeah. So you don't have to learn too many fancy debugging tools in 1511, just a pen and paper should be enough. And feel free to use this technique in labs. Your tutor should be able to help you go through this. It's a fairly common technique used by tutors in 1511. And yeah, it's an excellent tool to practice for the exam. So make sure you do lots of examples of these, and don't have the first time you encounter your linked list bugs be in the exam. Good luck.